All right, so I think this is recording. Let's take a look here at problem number 16. The directions are the same as the previous problem. Are f and g inverses of each other? Verify by finding these function compositions, f composed with g of x and g composed with f of x. And we have to make sure that we clearly show our work. There are other ways that we could determine if two functions are inverses of each other, but the directions specifically say to do it through this composition. All right, so if we do this first one, f of g of x, we're taking this function g and plugging it into f. So this function g is this ratio, and f always creates a ratio. F always creates a fraction where the numerator is always 3, and the denominator is always a subtraction problem. The denominator will take the input no matter what it is, whether it's an expression or a number, and it will subtract 2 from it. So what we have is this expression 3 plus 2x over x. So to simplify this, we could do a variety of things. We could look at this denominator and see an x and multiply it by x over x to get rid of that denominator. We could rewrite 2 as 2x over x, get a common denominator, subtract that, and then let's do it. Let's do that. Let's rewrite this number 2 as 2x over x, and now I have two fractions in this denominator, but they have a common denominator here, so I can write these two fractions as a single fraction if I just do this operation of subtraction. So look, I've got 3 plus 2x and then minus 2x, and that's all in the denominator there. So the 2x minus 2x cancels, and I have 3 over x. Now, this long fraction bar here, that's division. And we know that we can rewrite division as multiplication if you take the reciprocal of the divisor. The reciprocal of 3 over x is x over 3, and then the 3 divided by 3, those 3's cancel, and we get just x. So we're halfway to the way to our we're halfway in concluding that these are inverse functions, but we have to find this other composition and make sure that it also equals x. So we're going to take this f and plug it into g, and again we get another complex fraction. Now I'm going to erase this over here just so I have more room to work. I already know that simplified to x. All right, so what does g do to its input? G always creates a fraction. The numerator is always an addition problem of 3 plus 2 times that input, and then the denominator, it's always the input. Well, this time this input is this ugly fraction. And so here we could do a couple different things. We could multiply by the number 1 and write the number 1 as x minus 2 over x minus 2 to clear each of these denominators. Since it's a single fraction in the denominator, like last time, we could change that division to multiplying by the reciprocal and then distribute that through. Let's just go ahead and multiply this by the number 1, but we'll write the number 1 as x minus 2 over x minus 2. So to multiply fractions is pretty easy. You just multiply the two denominators together, and then you multiply the two numerators together. So in the denominator, I've got this x minus 2 that's going to cancel with that x minus 2, and this product is just 3. In the numerator, I'm going to take this x minus 2 and distribute it to both terms. When I multiply it times the first term, I just get 3 times x minus 2. When I multiply it times the second term, the x minus 2 and the x minus 2 there cancel, and I just have 2 times 3, which is 6. So let's distribute this 3. We've got 3x minus 6, and then plus 6. Well, the minus 6 and plus 6 cancel each other out. And we have 3x divided by 3, and 3 divided by 3 is 1, and we say those cancel, and we get x. So we conclude that, yes, these are inverses of each other. These are inverse functions. So if you wanted to, you could rename one of them. If this one is f, you could come over and rename this f inverse to make it super clear that they're inverses of each other. Or if you like the name g of x, you could rename this one g inverse. So there you go. All right, well, hey, I hope that helps. Don't be afraid to ask questions, and I'll talk to you later. Bye.